Hello everyone, I'm humanHardDrive, and today on our Arduino tutorials we're going to be continuing on with the second part of the I2C communication tutorial. The first one we did was communicating between the Arduino and an I2C addressable device. In that case it was an EEPROM chip. Today we're going to be talking about communicating between two Arduinos, specifically an Arduino Uno and my new Arduino Leonardo. Now, I2C is a really efficient means by which of communicating between not only two devices, but a chain of devices. And this can be expanded out to more than 100 other devices. So if you want more than 100 Arduinos to talk to each other, then this is probably the way you want to do it. Now, to do this, you're going to need a few things. Obviously, you're going to need at least two Arduinos. So here's my Arduino Uno, which I've got with the breadboard, so I'll be working with that, and I'll put that over there. You're also going to need some jumper cables, and quite importantly, two resistors. And in this case, these are 4.7 kilo ohm pull-up resistors. If you don't know what a pull-up resistor is, here's a link to another video I did on pull-up resistors. What these things are going to do is, because I2C cannot stay at a logic of 0 volts, these things help pull that up to 5 volts. So that's what we're going to do. Okay. First thing you're going to do is connect the I2C pins built into the Arduino Uno. In this case, those are pins A4 and A5. A4 is the data line, SDA, and that'll be connected over there. And then A5 is the clock line, which will be connected right here. And then I'm going to take both of these Arduinos, both of these resistors, and I'm going to connect them so that it is in line with this. I'm actually going to move these down a bit. So one resistor is in line with A5, and the other resistor is in line with A4, and these resistors are actually going to pair up on one more column. There we go. There we go. Alright, so I'm going to pull this up a little more. So A5 is going to go down this row, A4 is going to go down this row, and they each have a resistor attached to them. And then these two resistors tie together right here. Now, where those two resistors tie together, I'm going to attach another jumper to the 5 volt line, so VN ground, ground, 5 volt. And I'll provide a schematic for this because I know it's a little tricky to see with my crap camera. And I'm just going to bend the resistors out of the way so you can see. Okay, now what we're going to do is we're going to go ahead and attach these to the Leonardo. Now the Leonardo, because it is an R3 board, has SCL and SDA lines broken out. So that makes connecting it a lot easier. So pin A5 is the clock line, so that gets connected to clock. That's the top pin right there. Fingers in the way, there we go. And then we'll connect pin A4. These are in line with the resistors, and that'll be connected to SDA on the Leonardo. Now the last thing you're going to want to do, I've got these two jumpers set up. What I'm going to do is I'm going to attach them to the same power line so that they share common power. So this lead right here is being attached to the 5 volt line from the Uno, and that's going to be connected to the Leonardo, so ground, ground, 5 volts. Nope, miscounted. VN, ground, ground, 5 volts. And then the other one is going to be connected to ground, VN, ground, and there we go. So now these two are sharing not only I2C data communication lines, but power lines as well. So that keeps everything level and good. So now that we have this set up, we can run 2 bits. That's a number 2. 2 bits of code. One is I'm going to be using the Arduino Uno as a master device, and I'm going to be using the Leonardo as a slave device. And what I'm going to show you is 2 pieces of example code. One is master write, slave read, and the other one is master read, slave write. So that's the master sending data to a slave, and then the master requesting data from a specific slave, and that slave writing back the data. So let's go ahead and look at the first one, master write, slave read. Okay, so I've opened up the Arduino IDE. Now I'm using an Arduino Leonardo, so in order to use the Arduino Leonardo, you're going to need the IDE version 1.0.1. If you're using anything before that, it won't have the Leonardo built in. Sorry. So let's go ahead and get started. So I'll label this the I2C master code. This is going to go onto the Uno. Now the first thing you're going to have to do is include a library called wire. And that's going to set up all of the I2C, that's going to have all the I2C stuff built into it that you're going to need to do this. So void setup and a void loop. And what I'm going to do is, what I want to achieve is I want to be able to send a character via the serial terminal to the Arduino Uno to send a command to the Leonardo to turn on its LED. Now, I know it would probably be simpler just to hook up the Arduino Leonardo to the terminal and have it receive characters that way, but that's not going to demonstrate I2C very well. Okay, so we're obviously going to need the serial library, like I said, the serial object. And the wire library works very similar to that of the serial library. So you're going to say wire.begin. Now, because this is the master device, we don't have to initialize an address for it. For the slave device, we will have to initialize an address, as you will see later. So serial.begin, wire.begin. Now we've just got to receive the character from the serial terminal. So while serial.available, we'll use a character, c equals serial.read. And I'm going to set this up in such a way that you can see the similarities between the serial library and the I2C library. So if c equals h, we'll say y. Okay, save that. And else if c is l, that's low, we'll say that turns it off. And I don't need that semicolon there. Okay. Now there are 3 steps in order to start a I2C communication on the Arduino. The first one is wire.begin transmission. Now we're going to specify the address of the device we want to begin transmission with. And let's just pick a number. This can be anything from 1 to 127, or 0 from 1 to 127, but 0 is taken, I believe, by the master device. So 1 to 127, your choice. Okay, 5. And we're going to need to remember 5 when we go to write the slave code. So, and then we're going to say wire.write. And this can be a string of data, or it can just be a single character. And let's go with the same thing we're receiving from the serial. We'll say an H, and then wire.end transmission. And again, we don't have to specify which device we're going to stop talking to, because we can only talk to one device at a time. And L, it's the same story, begin transmission. We're going to talk to device 5. We're going to write, this time we're not going to write H, we're going to write L, no, to turn it off, and then we're going to say wire.end transmission. And that's all you really need for the master code. So let's go ahead and set up the slave code. Make this 2 windows. Gotta love Windows 7. I2C slave code. Gonna label this again. And this is gonna go on the Leonardo. And again, you've got to include the wire library. Make this full screen for the moment. Void setup. Void loop. Okay. Now, for the slave code, it's going to be a little bit different, because it has to recognize when it's received communication over I2C, and the way they have that set up is using events. It's like interrupts, but they call them events. The difference being interrupt is usually hardware, event is more software-based. So, wire.begin, and we want to control that LED, but we're going to give it an address. Again, remember 5? Yep, right there. That's where it comes from. So we've got to call it 5 so that it knows what address it is. Let's say pin mode
13, make that an output so that we can control it, and we're going to turn it off. Okay. Now the event is any function you want. You can call it anything. So we're just going to call this receive event. So I just call this receive event. That way it's easy to recognize, and I can just call it so I know what it is. This int how many is required by the event handler, and what it does is that variable is going to be, it's going to store how many bytes it's receiving from the master device, from the thing it's receiving the data from. That's not really too important right now. I know that has some usefulness, but it doesn't really have it in this application. So we've created the event. Now we just go up and say wire.on receive. You'd be surprised how tricky it is to spell receive. And then on receive, and then we're going to say what the function is called, and it's receive event. Move my mouse out of the way. And that's it. So when it receives data from the master device, it's going to jump to this function. And it's within this function that you're going to parse the data, pull stuff out, or do what you need to do. And in this case, it's going to be turning on or off the LED. So while wire.available, again, it's just like serial. Char C equals wire.read. Yeah, looks similar. If C equals uppercase H, else if C equals L, digital write 13 high, digital write 13 low. Okay. Now you'll notice on the slave side you don't have to do any of the handshaking that you did on the master. The master takes care of everything. The begin transmission, the writing of the data, and the ending of transmission. All the slave device has to do is interpret the data. And that's really it. That's all you need. So let's go ahead and download this. Now we're going to start with the slave. If you're using more than one Arduino, here's a little tip that I figured out. If you're going to be downloading more than one program at a time to separate Arduinos, don't have them hooked up at the same time. It doesn't work. Don't know why, it just doesn't. So we're going to make this the Leonardo, serial port 12, download it. And now we'll just go ahead and unplug the Leonardo and then plug in the Uno, because the Uno is the device we have to have plugged in, and because they're sharing a power bus, the plugged in Uno can power the Leonardo. So now we'll just go back up here, select Uno, select the serial port, and then upload it here. And now that that's uploaded, I'm going to open up the serial monitor, punch in an H, punch in an L, and as I'm doing this, I realize you can't see what it is. So let's go ahead and look at the board while I type in H and L.
Okay, so what I'm going to do, because it's tricky to see the LEDs with the light on, I'm going to turn it off. There we go. Okay, so you can see even though I have one USB plugged into the Uno, both devices are powered. Now what you're looking for is this LED right here. This is connected to pin 13. Even hold it up a bit, move that cable out of the way. There we go. So if I hit H, capital H, it turns it on. Hit lowercase h, or uppercase L, turns it off. Uppercase H, on. Lowercase L, off. And so that is it for, let the light readjust, there we go. So that's all it takes to send signals from one Arduino to the other. Now this is part one, this is sending messages. Now we're going to go ahead and use the Arduino Uno to ask this, the Leonardo, the slave device, to send data back to the master. So first part was Arduino Uno, master, sending data to the Leonardo, slave. Second part is sending data from the slave, the Leonardo, back to the master. So let's go ahead and look at how to do that.
Okay, so keeping things the same, let's start out with the master code, which is still going to be the Arduino. Put that in parentheses. Okay. Again, going to include wire.h, void setup, and void loop. But we're going to kind of ignore the loop function because we want this to run one time round. Wire.begin. Again, we're not going to give it an address to start with because it's in the master device and it's not really necessary. And we're going to say serial.begin because we're going to be asking it to print out some data for us. Now, I'm going to leave the master code like this for now because the slave code is really more important in this example. Why? Because we're asking the slave device to send us data instead of just sending it data. Yeah, which is the Leonardo. I can spell. There we go. And include wire.h, void setup, and wire.begin. And we're going to use the same address as we did last time, so let's use I2C address 5. Now we're not going to be using serial or really anything else. Void loop, again, another function we're going to be kind of ignoring. We're going to put one thing in it. Okay, now, for the master write, slave read, the slave had an event called request event, or not request event, thinking ahead of myself, receive event. That is, when it received data, this event was called and it did something. This time, there's an event called request. So when the master device asks for data from the slave device, this method is called. Now, this method doesn't require any parameters, unlike the receive event, and it's just wire dot on request instead of on receive, and we're just going to tell it what the name of that event is, request event. There we go. And we're going to put in a little bit of delay here. I find that helps smooth things along. It's just I've tested this before, and what happens is sometimes it doesn't work, and when it doesn't work, I try to put delays in a few places that make it fit. So, oddly enough, that makes it work. Okay, what are we going to do on the request event? We're going to write, and remember, write can also send strings of data, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. That's outside the quote. And I want to write this list of data because I want to demonstrate an effect, tongue trippy there. I want to demonstrate what a certain line of code can do. Now, if we go back to the master code, because that's all we really need for the slave device, we're going to say wire.request from. Now we're going to give it the address of the device we want to request from, address ID 5, and then the number of bytes we want from the slave device. So we can actually choose how many bytes we request. So if I ask for 1 byte, I'll get the number 1. If I ask for 2 bytes, I'll get 1 and 2. 3 bytes, 1, 2, 3, and there are 10 bytes here. So let's say I request 5 bytes. So I should get 1 through 5. Now this time, it's going to be the master device which has to parse through the data. While wire dot available character C equals wire dot read. It helps if you actually store it to an external variable. It makes things move smoother. Again, it's like that delay over there. And then we're going to say serial dot print C. And that's really all you need. So let's go ahead and plug in the Leonardo. And then download download the slave code. Okay, so it's been uploaded to the slave device. Let's go ahead and upload to the Uno, the master device. And again, remember they're on the same power bus, so they're both powered when one is plugged in. Let's change it over to the Uno, COM port 4, and upload. Okay, so that's done uploading, and if we go to the serial monitor, we should see 1, 2, 3, 4, 5. We have successfully requested 5 bytes from the slave device, and it's given us 5 bytes back. So that's 1 through 5. And if I ask for all 10 bytes, upload it again. Upload and... check the serial. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. So that's all 10 bytes. So this is the master device requesting a specific number of bytes from a specific I2C address. Now, there is one other thing. There is a Boolean operator you can put at the end, either true, that's not true, true, or false. Move that out. So, true or false. And that's the stop. So if I put true after this, then when it's done, it's going to send a stop bit, meaning I only want 5. I only want 10 bits, 10 bytes, stop. Or I could request, now if I put that as false, it's not going to send the stop bit. So that's useful for if I want to do some other stuff. I don't want it to stop talking just yet. I might need to send some other data. I don't want to cut off communications just yet. So it's set default as to false, or not false, true. That stop bit set. So if you really don't need to do anything more with it, just leave it as it is. So that's really it for I2C communication between Arduinos. I hope this has all made sense. If it doesn't, I explained a little more about I2C in the EEPROM thing. I can put a link to that here. But other than that, that's it. So this has been humanHardDrive. Thanks for watching.